We only build 20,000 new homes each year in New Zealand. So what options do we have for improving the existing ones? Welcome to the Pro Climber podcast. In today's episode, I interview Jon Davies. Jon holds a Bachelor of Education as well as a Master of Architecture. This week, we discuss an external side retrofit option called Parka Wrap. This seeks to radically change the overall performance of our buildings without having to move the occupants out. It's unbelievable that 1.5 million New Zealand homes have no insulation in the walls. So let's get started. ProClimber inspires and educates people to create healthy, durable and energy efficient buildings to live, learn, work and play in. Welcome, Jon. How are you doing today?
Yeah, good, thanks. Good, Simon. How are you doing?
Yeah, awesome, mate. Great to have you back here at ProClimber with us.
Yeah, well, it's good to be back. It's a bit of a little holiday I've had for the last 4 years.
Exactly. No, it's great to have you back. Now, Jon, I've got a sort of standard question we ask most of our guests at the beginning of the podcast, and that is, what book do you have on your bedside table at the moment?
Oh, no. Okay, I know what the book is and I know what it's about, but I can't remember the name of the title or the author right now. And the irony is it's a book about words. It's about the phrases and words and where they've come from, like a history. It's kind of like a Simon Winchester kind of style, but I can't remember the name of it. That's really poor.
That's all right, Jon. What we can do, once you come back to us with the name, we can stick it in the notes of the podcast notes below so people can. So you're enjoying it?
Oh, it's really interesting. I mean, it looks at a bunch of small words, like even the word a or a, and how that has come into use into the English language and how it sits against a whole lot of other words. So even, like the word aboard, well, it used to be on board, meaning get on board a boat. So it's just all of that sort of, that history. I enjoy that sort of thing.
Awesome. Now, Jon, to kick things off, can you give me a little bit of an idea about when you were growing up? What did it feel like living in the house that you lived in? Whereabouts did you grow up in New Zealand, and what did the house feel like? How did it affect you?
Well, the house is still there. It's still our family home, actually.
Oh, wow.
Now, I say that my mum is still there, and the home has changed quite a bit. When we grew up in winter, it was pretty cold. I mean, it didn't have any insulation. We're talking about in the 70s. And I just remember a very short, like about a foot long bar heater that would sit in the kitchen and that we would stand right beside above in the mornings before we went to school. So that's my recollection of that home in winter. Cold. It was very exposed on the site. So when it was windy outside, it was definitely windy inside. But yeah, the house hasn't changed a heck of a lot since then. Actually, not much more insulation anywhere. And yeah, it could be improved.
I specifically remember those bar heaters. It was like a red glowing thing in the middle, wasn't it? It had this big reflector dish at the back.
Well, this was tiny. This was 1 foot long, and it had little metal feet, little legs, like really short. It was right down at floor level, and it would sit. I think it was plugged in to one of those old oven power points.
Yes, on the side of the stove,
on the side of the. And that was probably about our heating. I know we had a fireplace, but yeah, that wouldn't have heated much if it was windy. Would have heated a bit of space, and then that would have been blown out through the. But it was an old batch at the time, and it was home. It was still home, and we didn't know any better.
That's the thing, isn't it? And so really, that was the only heat, wasn't it? The rest of the house, you were just freezing. You just had to make do to keep warm however you could.
No, we had hot water bottles, so we were good.
And what about damp? Was it damp and mouldy at all?
No, that's one thing it didn't have was any mould, and I don't remember it being damp anywhere.
Good thoughts there, Jon. Now, when you finished up school, you went on to study as a teacher, didn't you? What was the reason you went down that path?
Oh, that's a good question. So I ended up primary school teaching. I had done a lot of work with young people at that time. Even as I left school, I was coaching in the local gymnastics club. I'd been involved with lots of children's camps, Kiwi Ranch and Rotorua, spent a lot of time doing that. I just enjoyed that world and ended up teaching. And yeah, loved it. I loved the teaching part. I loved the classroom. I didn't love the paperwork.
I can imagine. I believe nowadays teaching has become even more admin sort of focused, hasn't it? There's a huge amount of reporting back and things required.
Bit of bureaucracy, but it's still good. It's still a great profession to be involved with. And now I'm sort of blending that back into what I'm doing now.
Yes, that's right, because you're now the technical and training manager here at Proclima, aren't you?
Yes, I think it's technical and education manager, and that's Australasia. So yeah, and it's combining everything I know from that teaching side within our company, which is a technical products. So it's a really nice blend.
Interesting. Yeah, I mean, we interviewed Ben not long ago, and he also had a similar background, didn't he? Which is quite interesting.
It's very similar. Teaching, building, technical. Yeah, very, very similar to my track.
Awesome. Now, when you'd finished your training, you went on to Scotland, didn't you, on a PE scholarship?
Yeah, it was actually during my training. I was selected. So I was in the middle of primary school teaching training, and the role that was offered, or the scholarship was being offered at a boarding school in Scotland, and we actually had 3-year-olds up to 18-year-olds within the school. So they needed a primary school trained PE teacher, and I ended up there for a year and had an absolute brilliant time, learned a whole lot, learned how to ice skate and, just all of the stuff which is just not that normal here.
Scotland is amazing, isn't it? I remember working in 1995 in the Tarbert Hotel called the Stonefield Castle Hotel. It was amazing. It was out on one of the lochs on the western side of Scotland.
Yes.
It's just amazing. I remember working in the pub there. It was just awesome.
Oh, okay. So I was there in 96, so almost crossed over.
Yeah.
I'd forgotten. I think we've talked about that before, but I had forgotten. Yeah.
So how did you find the buildings like to live in Scotland versus New Zealand?
Oh, that's a good question. So all of my time there was at a boarding school. So we had, there were 5 different campuses within that school in the little town in Helensburgh. And the setup there was the school buildings were old houses, big houses. And so they were solid stone, and they had heating in them, which had to be on. If you turn that heating off, it would be cold, like the outside cold. So there was no insulation, but they were very, very heavy buildings. So very high mass stone, keep it warm. I wouldn't say that they were incredibly comfortable. It's not particularly comfortable living in a castle, and it's the same sort of thing. The walls weren't quite as thick as a castle, but uninsulated stone, when you let it get cold, it's cold.
But you did have this permanent central heating. Yes. So wherever you went in the building, at least you were warm, wasn't it?
Yeah, that's right. Then we moved from the boarding house. We'd just got married, so my wife came across a little bit later than I did. We moved to a stable, a renovated stable. So we had the top floor and that just up from the school. That was much colder. So that was insulated, but to heat and to afford that heating, we couldn't do it. Wow. And so, we just tolerated that. It was a little bit silly, but it's what it was. So lighter weight building, not well insulated and hard to heat and cold.
Interesting. So later on in life, you decided to move away from teaching and move into the building industry. What prompted that choice?
Oh, well, we ended up, when I finished teaching, so I'd been teaching about 6 or 7 years at that point, and when I finished teaching, we went back to the UK, worked for a travel company, and when we'd done our time over there, we spent 2 years in London. We came back because my wife was offered a role at a local secondary school here in Auckland, and I didn't have a job to go to. When I came back, I wasn't too excited about teaching, but a friend of mine said, why don't you come and swing a hammer with me? And so I worked for him. It was going to be temporary, turned into a 4-year apprenticeship, and I really enjoyed it. And the difference with building versus teaching, when you build, you pick up a hammer, you pick up the timber that you're working with, and you make something, and when you've finished making it, it is finished. When you start teaching, nothing's ever finished. No child is ever finished. The enjoyment in building was actually starting and finishing something and seeing an end result. Now, the flip side of that is 10 years later, I had students come to me. I went back to the school I'd been teaching up at Gulf Harbour, and a student walked in the door and she said, "Hi, Mr. Davies." And I looked up at her, which is not very hard. I'm not very tall, but I looked up at her and I didn't really recognize her. She had a baby in her arms, a woman at that point, and I got into conversation with her and she said something along the lines of, "You are the reason I was successful. You made school enjoyable at the time." Now, that's really nice feedback, but it was 10 years too late. I needed that feedback like now, and that's the missing. If you can deal with that as a teacher, if you can enjoy what you're doing and somehow see into the future and think, actually what I'm doing is worth doing, it's good. But if you need instant satisfaction with what you're doing, choose something in a trade that you can see, that you can start and finish and see and enjoy the completed result.
Interesting. Now, after you did your building apprenticeship, you actually took off some time, didn't you, to actually work on your own home and look after your boys at the same time. Tell us about that.
Well, that crosses over with my time starting at ProClimber. So I worked in the head office at Mitre 10 for about 18 months and was introduced to the ProClimber products during that time. So the ProClimber products, we were bringing those into the country. We took our first containers of material in. I hand unloaded those into our warehouse. We were selling those products, but we weren't really getting traction in the market. It was a real challenge to change anything in our building industry. Like a lot of industries, it's a radical change what we were presenting and what we were promoting. So I stopped working for ProClimber and stayed at home with our two boys. And I renovated our family home during that time and had a lot of fun doing that. And I used ProClimber products because that was the smart move. There were lots of things I learned along the way, some things that I kind of regret. We didn't have enough money to put really good windows in. We only put thermally broken aluminium into the building. So I would have changed, I'll change that in the next renovation. But during that time, it was 3 years. That sounds like a long time to renovate a house. But I met a Dutch family who were out here on their round the world trip, and I ended up doing a bit of work on their boat, and we ended up sailing up to Fiji, and so it was all of those cool distractions that happened during that time as well.
Now, I've been to your house, John, and I might have it not quite right, but am I right in saying there was a brick and tile sort of 70s build, was it, or 60s build?
Yep, that's right. Yep. Yeah, that's right. It was 1970, brick and tile. It was a 2-story. Yeah, it was just the very, very typical, that red-brown brick on the outside, timber windows, no insulation. A little bit of insulation in the ceiling, but quite old, sort of poor quality, that fluffy blown-in cellulose.
Exactly. And I'm assuming at that time it would have been pretty cold, drafty, not that comfortable to live in. But I remember when I visited you there, when I started working at ProClimber, and your house was warm right throughout, wasn't it? So how did you achieve that, John?
Well, all of the wall linings came off, and I worked from the inside of the frame and put wall underlay at the outside of the framing, which is a bit of a challenge for any build. In this case, it was with the cavity and brick. Then those frames were insulated, so 90 mil of insulation. And then I used the Intello airtightness product across those frames. So the whole building has the Intello layer across the walls and the ceiling. So the insulation is now continuous across the ceiling and down the walls, or as continuous as you can when you put it between frames, right? So it's still chopped and stopped insulation. It's still insulation, framing insulation. And I didn't do the internal service cavity. The rooms, it was a small building, right? It was a 70 square meter, 2-bedroom home. So those spaces are not big. So to lose floor area by increasing the wall depth was just one step too far, which I sort of regretted later because it creates more work. I wish I had done that and ended up with smaller rooms that were working better than they were when I finished. Yeah, I made some mistakes along the way. The position of the windows was a challenge. I didn't plan that well enough. It sat on a block base, and it was the old garage that I renovated or sort of modified to be an internal space on the lower floor. So yeah, lots of things that worked and a good number of things that you learn a lot from and think, right, I could do better next time.
Now, Jon, as part of that, you also put in a ventilation system, didn't you?
Sure did. So it's my view on the world now that it doesn't matter what you do. It doesn't matter what changes you're making, even if you make no other change, adding in a balanced pressure ventilation system, so that's a fan-driven, it's a mechanical ventilation, is just the first thing that you should do. It's a no-brainer. It changes the way that the building is working, not for heat initially, but for fresh air. So when it's windy, a drafty building has some air movement through it, but it's infiltration, it's drafty. When it's not windy, nothing happens. Even if you open windows, if it's a completely still day, you end up with no ventilation through your home. That's the first thing. And so, as you know, I've moved to another house. In fact, we moved straight across the road to a very old, 80-year-old Art Deco home. It's way draftier than our other home. It still is, because I haven't done anything to the building yet. But the first thing I did was put a balanced pressure mechanical ventilation system in. So I've used a Steel Eltron system, and it pulls fresh air in from outside. That air gets pre-warmed from the outgoing air, and it gives me fresh air into the living rooms and the bedrooms. That's key. That's the first thing I would do in any renovation, is ventilate.
Now, Jon, how would you answer? I hear a lot of people saying, why would you want to be pushing air into your house using fans? Aren't you just using a whole lot more energy to do that?
Well, it's not a whole lot more energy for a start. So the systems use very low powered. So it's a low speed. We're not talking about jet engines of air being pushed through the home. It's a low power fan. Two fans really, one of them extracting air from the wet areas and putting that air outside and bringing in fresh air from the outside. So the key bit really is when a house is working well, when it's well insulated and when it's heated adequately, the outgoing heat is given to the incoming air. And when you do that, let's do some maths there. If you recover 90% of the heat from that outgoing air, that means that you can use that air, the heated air, or the heat in that air, let's call that 9 times before you have to reheat that air again. So that's a little bit of a tricky concept, but simply put, you're recovering the energy that you've put into your building. You're recovering that 9 times before you have to recover or before you have to put heat in again. I think I just kind of repeated myself on that. It's a question of how much did it cost to heat. If I heat a building, so let's talk about a different type of building. If I put heat into a building and I lose 100% of that heat, I have to put 100% of heat back into the building to do it all again. But if I can recover 90%, then you start to see very quickly an energy saving, because the cost of running the fans is massively offset by the heat that is recovered through that system.
Yep, that's a good answer. So what sort of energy are you using? Just how many watts did those fans run on? Can you remember?
Look, I remember the numbers. I don't have that number for the current system that I have, the Steel Eltron system. In the old house across the road, I put in a Zender system, and I'm pretty sure that it was pulling 28 watts of power across the 2 fans, and it's less than a 60-watt light bulb.
Exactly, which is next to nothing. I mean, now we're probably using LED bulbs that maybe use 5 or 10 watts each, but still, it's a fraction of tiny bit of electricity, isn't it?
So I guess that other part of that question is, well, when do you turn that system on? Well, you turn it on once and you leave it running. You leave it running 24/7. It's always extracting air from those wet areas, your bathroom, your laundry, and the kitchen area. You're always putting fresh air back into the bedrooms, and it's just at low speed and a well-designed system. You shouldn't hear it at all, and it shouldn't be drafty either, so it's not a comfort problem. It should be just fresh air being brought through, and it's not now a luxury. Like, fresh air shouldn't be a luxury. You know, when you jump in your car, you switch on your car and you've either got aircon running or you've got a fan running. If you switch your fan off in your car, you will very quickly find out that it's muggy, it's hot, it's muggy and humid. I was looking for another word in there, but high CO2, that's kind of part of that mugginess as well. So we ventilate our cars really well.
Exactly.
And it's controlled, right? You can be traveling at 100 kilometers an hour down the road and you've got fresh air, which doesn't need to be blasting in your face. But the other side of it, people say, well, in fact, I had a person yesterday say to me, but I also like hearing the birds. And then she answered that for herself and said, but I can also open the windows when I want to. And I think that's a really key part, that when you achieve airtightness on a building, when you target airtightness and you have, windows closed for efficiency, it does not stop you opening them when you want to. But when you want to close out the rubbish weather, the high humidity, the storm, the rain, whatever's going on, then you can, and you still have fresh air rolling into your house.
Exactly. So once you'd completed that project, you came back and started back with ProClimate, didn't you? What changes did you see in the industry over the time that you left ProClimate, came back to ProClimate?
That was a fairly short gap, just a 3-year gap, if that's one way to look at it. Not a lot had changed. We had changed as a company, but there were still 3 of us. There was still Thomas and Cy Gibbon and myself. We were at that point, and in a way still are, Auckland, Wellington and Christchurch. We had a huge challenge to change the way of thinking in our industry about airtightness. And at that point, there was still the misquotes going on. So brands had made a statement that said, our houses are becoming too airtight if we are to rely on opening windows to achieve adequate ventilation. And I've got that almost word perfect there. But the problem was that it was misquoted and it was shortened up, and people only heard the first bit of it. And it said, our houses are becoming too airtight. So that's been a fight, and it's not against brands, it's against how the industry has picked that phrase up and used that for a long, long time. And I think there's still, definitely still people who would say, aren't our houses becoming too airtight? And it's pretty much from that phrase, that misquoted phrase. So our houses are not becoming too airtight. It doesn't matter whether you use our products or not. Our houses are becoming poorly or more poorly ventilated, and that's a different animal, different game. So we were going really hard out in the industry trying to get that message across, and it was hard work. I was doing all of the takeoffs. We were doing presentations to architects, and we were trying to get traction, and we did, and here we are today, even though I've had a holiday again. So this is the 3rd time I've been back, 3rd time starting with ProClimate.
Yes, that's right. And in between, you did a stint at Oculus, didn't you? Tell us about that.
Yeah, 4 years at Oculus. That was a really interesting time. That company, Oculus Architectural Engineering, so it's a facade engineering company that deal with envelope engineering. So it's sort of one step more than just facade. Typically, facade engineering, people think about the vertical surface, windows, possibly cladding, skyscrapers. But when you look at it from an envelope engineering perspective, that includes roof, it includes walls, it includes subgrade. So I ended up on a bunch of really interesting projects. Te Matawai was one of them, which is the Kāinga Ora apartment complex. So 276 apartments in Grays Ave in Auckland Central. That was a really, really interesting project because we put external insulation onto that building, and the design and the changes in the industry have really kicked on with the acceptance of external insulation into buildings, not just because of that project, but that was a significant one. So that was pretty exciting to work on. And then we ended up, during COVID, we built a test facility in our workshop. We built a test booth in our test facility. So that was for NZS 4284 testing, which is wind and water and seismic. So it was a big steel box, 6.5 meters high, 5.5 meters wide, and we would build walls into the opening of that, so one whole wall of that box, and then put wind and water and seismic pressures onto a facade. And it could have been a cladding test, it could have been a joinery or window type test or a door system. And that was during that time when we just set up, one of the lockdowns occurred and we didn't have the ability to have clients in. So I had the booth all to myself. So I used it for a research project.
Awesome. And that brings us on to your next project, doesn't it? The Parka Wrap. So where did you come up with this concept? Why did you call it the Parka Wrap?
Well, I didn't call it Parka Wrap. Peter Raimondo did. I named his research topic Tall Brick, which is yet to be, I think, worked on and completed. If Peter hears this, he'll be like, come on, let's get on with that project. And he named mine as Parka Wrap. Now, Parka is an Inuit word, so Parka, and that is the coat, the insulated jacket, which you'd put on to prevent yourself from cooling off. So think of a puffer jacket, same kind of principle. Parka Wrap is the name of the research, the name of the thesis that I did for a Master of Architecture study, and that was by project, so it was through Unitec. So I did that full-time while working full-time and in the middle of COVID. So it was kind of a good challenge. But the Parka Wrap idea is the idea that instead of putting a coat on one person, you would put that around a building. And so that's what I tested using external insulation. So I built up a replica wall, 1940s wall. So I bought Remu weatherboards from the local demo yard and found a timber window which had an awning and a casement. I built that into a wall and put that into our test booth. And I looked at how that wall performs when you hit it with wind and water and seismic. And it turns out that it works really, really well if you leave the wind off. So if we just used water and seismic on that wall, it was actually really watertight, or at least really good at deflecting water. I wouldn't say watertight, but good at deflecting water. You could see the water from the inside of the weatherboards. You could see the water sitting on those weatherboards. But it was when we turned the wind on that we pushed water up through the boards and through the window system. And that's typical of, or largely typical of, our housing stock that is timber frame, timber windows, timber weatherboards. They work really, really well until we hit the storm, and then they dry out really quickly as well. So instead of pulling off from the inside, instead of pulling off plasterboard, I worked on the outside of the wall and I installed a weathertight layer, which was the Solitex Adhero, so a ProClimber product. And then I used Rockwool as the external insulation. Now, Rockwool doesn't mind getting wet, and that it doesn't collapse when it gets wet, and it drains quite freely, it dries out quickly if it does get wet. So I tested some of that, and I used some other international research that had shown that that occurs as well. That work has turned into the Parka Wrap system, which is kind of a Parka Wrap process of investigating the structure of a building, working out what needs to be done, adding layers on the outside of the existing building, and then new cladding outside that. So your new layer. So if you imagine a wall, you don't need to take off the existing cladding, and you need to check that the structure is sound. You need to check that it's adequate for putting more layers or more things on the outside. And then you're adding layers to the outside. What that really means is you don't need to move people out of a building to do this work. Now, it doesn't mean that people don't or can't move out, but you don't need to. You're working on the outside, from the outside, and that's the beauty of the system.
Awesome. And you've got your first project going at the moment, haven't you, out near Auckland Airport? And that's with the ARA
Educational Charitable Trust.
Yep. There we go. Thank you.
Yep. So that's good. So ARA Education Charitable Trust is a group which is on airport land, funded by the airport, and they bring in students from 5 local secondary schools. It's an amazing facility out there. They've got, I think, about 7 or 8 homes on that site at the moment. They're relocatable, so they've been moved onto their site, and we've got one of those. And so the team there, we're working with them. So they're doing the internal part of the renovation to the home. And when I say internal, that's repairing some plasterboard. It's an existing, slightly damaged home. But we've got the outside. And so we are applying for the whole building. We've got multiple sponsors involved there. So we've got Proclimer as a sponsor of the product. We've got Neuralite or Outright Insulation as a sponsor for the rock wall insulation. We've got Stark Windows. So they are providing the UPVC double glazing from them. And then there's a company that's kind of ours related to Parka Wrap that provides some of the clips and the connections from the existing structure out to the new cladding. And then we've got a fibre cement cladding from FCS, Fibre Cement Solutions. And then we've got a Steel Eltron ventilation system going into that build as well. So we're right in the thick of that right now as we record this, and it will well and truly be done by the time this gets published. The reason for that is it's about a 3-week process, all going well, when all the materials are ready to go onto a build. So looking at the existing structure, adding Proclimer Adhero on the outside, putting new windows in, connecting those windows to the Adhero, adding insulation on the outside, battening outside that, and new cladding on the top.
So John, why is it so important that we upgrade our existing New Zealand housing stock?
Yeah, that's a great question. It's because they're there. It's because it's not realistic to expect us to change, to demolish every home that needs help and just put a new one there. And that's a monetary, that's just a practical, that's just a skills. So we just don't have enough people to do that, to just instantly change from our buildings being poorly performing to much better performing buildings if we look at new builds. So that's a challenging question because we also can't do what we're doing fast enough to make an appreciable difference, this week, this month. We need a lot of people involved, and we think that's possible, and we don't have to control that solution or that system. It's an idea that you can apply in different ways to different buildings. But I think if you look at some of the numbers, and so my research focused on tenanted homes. So that to me says, should be by law, they'll have insulation in the ceiling and if possible under the floor. And that means that they're RTA compliant, or the Residential Tenancies Act compliant buildings. So I looked at those homes. Those homes, very typically, there won't be insulation in the walls. There'll be insulation in the ceiling and floor. There are 830,000 of those homes in New Zealand. So there's a lot of work to be done if we're going to improve those. And that's not my target. That's the target should be of our industry, to look at what those homes are doing for the health of the occupants. And we can improve those. That's the target. So 830,000 homes have no insulation in the walls. But there's one more slightly scarier figure. And that is, it's a lower number, but it's on top of that 830,000 homes. So 830,000 tenanted homes, approximately. 720,000 more homes have no insulation anywhere. So those are owner-occupied buildings. That's a much bigger challenge to change, simply because none of this work, whether you renovate from the inside or whether you renovate from the outside or whatever you do, it doesn't come for free. The labour, the materials to improve homes is relatively significant. So it's a better option still to improve our existing buildings than it is to demolish them and rebuild something new.
Awesome, John. So we're running towards the end of our time for today. Now, we've had a look at your history, where you grew up, move into the education side of your life, the building, and then obviously working with architects and builders to help them to build better places. Now, what do you see as the future of New Zealand? Where do you think we'll be in 10 years' time with the building code? Will it be offering us homes that are going to be healthy, energy efficient, sustainable? What do you think?
We've had recent changes to elements of the code, the H1 changes. What is interesting, in my view, on that is when you change an H1 requirement, so that's the energy efficiency requirement, what you are changing in real terms is the new build. that forces new build to be improved. And if we look at the numbers game there, let's say we build 20,000 new homes each year. That's okay. I'm not saying that that's a bad thing, but it's a very small number when you consider that there are 1.5 million existing homes that don't have insulation in the walls for a start. So I'm looking at that as a bigger challenge. I think our renovation market is enormous, and I think that's the focus that we should be putting some requirements, whether that's legislation. I mean, just tying this back into the Parka Wrap solution or that type of way of working, one of the things there is you don't end up with this ridiculously thick wall of masses of insulation to get to international performance. You end up with a very small amount of insulation on the outside of the building, which is working really well because it's a blanket. It's like putting a puffer jacket around yourself. It's like putting that around a building, and that insulation is continuous. It's in a continuous blanket of insulation around the outside, and that means that it performs really, really well. Now, what's the connection there? We're not trying to change legislation. We don't need to do that for renovation work. You typically will open up a wall and put insulation into the space that is there for a renovation. And what we're looking at is the ability to possibly put some expectations around the outcome of performance. So in answer to your question, which is a little bit of a roundabout way of getting there, what will we see as change? I think I hope we will see a change in the outcome for renovation work, which has energy modelling and predicted energy demand for that building, for any building, in play during the design process, and then just put some minimums around that.
Sounds like a great idea, John. All right. Well, thank you very much for your time. Now, I'm hoping to catch up with you again in the near future because you've got another project. Just give us a 5-second intro. What is the other project that you're working on at the moment?
Which one? Go on, tell me, which one?
Come on, you've got another project which is incorporating a whole lot of different products and things, isn't it?
Oh, the Ecovolution?
That's the one.
Yeah, so the Ecovolution Alliance is a group of German companies. So Proclimer is one of them, and I'm part of the leadership of that from the Proclimer side. Now, that's quite exciting because the companies are actually very much represented within the Parka Wrap group, if you like. So Stiebel Eltron is in there. We've got the Proclimer products. We've got a different Windows supplier in that group, Energate Windows. We've got Gutex, which is a wood fiber insulation. Did I say Stiebel? And then Lunos as well. So Lunos, yep. So that's just another ventilation offering with a decentralized system. So it's a group of German companies who are banding together to provide some solutions to this retrofit challenge. Simply, again, those numbers, the numbers of our existing buildings that can be improved for the health of occupants of those buildings of New Zealanders. That's the exciting part for me.
Awesome, John. Thank you for that. We'll end it on that note. Sharing knowledge is at the heart of our strategy to make buildings better for everyone. Sign up for our podcasts to learn more about creating healthy living conditions by protecting building structures from external and internal moisture damage. Thanks for listening. Looking forward to having you with us next time.